Alright, so we're basically going to be doing the same thing that we've been doing, only this time we're going to use variables instead of just concrete numbers. Same concept as before. So I can rewrite this as x to the 2 halves power. I could write this as x to the 3 halves, and so on. So I pretty much want to follow the same rules as before. I don't want my exponents to be anything except either an integer or a proper fraction. So obviously letter A is just x to the first, so that's just x. So that's an integer exponent. 3 halves, that's not a proper fraction, so we would want to basically treat it as if it was like 2 to the 3 halves. We want to break it into 2 halves and 1 half. So x to the 2 halves is just x, and then x to the 1 half converts back to the square root of x. 4 halves is an integer, so we can go ahead and just write x squared. We're going to kind of keep that trend going, so we have 5 halves that can break into 4 halves and 1 half. And so you're going to get x squared and then root x. And this pattern's going to continue, so you're going to get either an integer or a fraction. So you're either going to have a root x or no root in your answer when it comes to square roots. So go ahead and finish E through G real quick, and then we'll compare answers. So hopefully you get x cubed root x, and then x to the fourth, and it would just keep continuing. So the next one would be x to the fourth root x, and then x to the fifth root x, and so on. So we'll do another round here, but we'll focus on cubed roots this time. Again, same concept as before. So we're going to go ahead and rewrite these as exponential expressions. So we have x to the 3/3, x to the 4/3, and then you can go ahead and finish writing C through E there. So we have 5/3, 6/3, 7/3, and we could obviously go on forever. Same rules as before. We want integers or proper fractions as our exponents, so this is just x, of course. We could break this into 3/3 and 1/3, which would make x cubed root x. We could break this into 3/3 and 2/3, which is x. Now this is going to become the cubed root of x squared. And then we get a nice pretty squared. We can break this into 6/3 and 1/3, and so we get x squared cubed root of x. So we pretty much treat it the same way as before. So what I want to go ahead and do is first have you go ahead and convert all of these to exponential form, and then if you want to pause the video, we'll see if we have the same starting setup, and then we'll go from there. So hopefully you have your 4/4, 5/4, 6/4, 7/4, 8/4, etc. And just while I'm looking at it, if you notice this says 6/4, it's silly to work with 6/4 when you can really just work with 3 halves. So if I can reduce a fraction, I definitely will. So what I want you to do now is go ahead and separate them so that you have either an integer or a proper fraction in your exponent, and then see if you can simplify from there. So we should get x quartic root x square root x, and then x the quartic root of x cubed, and then finish with x squared. So what I'm going to do for these next problems is, I recognize like right off the bat 8 is special. I know 16 is a special number. 54 is not special, but I know it contains 27, which is special. So I'm going to go ahead and I'm going to rewrite these all as prime numbers and put them all in parentheses with the exponent outside. So for example, for letter A, I'm going to change 8 into 2 cubed. I'm going to keep the x squared and the y to the 9th. And then I'm going to take that whole thing, that radicand, and I'm going to raise it to the 1/3 power. So I'll go ahead and I'll change 6 into, you can do 4 squared. I actually like to do 2 to the 4th because 2 is a prime number, and I like to work with prime numbers. Usually saves me some excess work. And I'll raise that all to the 1/4 power. Now 54, I know is 27 times 2. And I know 27 is 3 cubed. So I know 3 cubed times 2 is 54, and these are both prime numbers, and that's what I like to work with. So I'll just leave that like that and raise that all to the 1/3 power. 64 is 8 squared, but 8 is 2 cubed. 2 cubed squared is 2 to the 6. So I'm going to change 64 into 2 to the 6. keep the a to the 10th and the b to the 13th, and I'm going to raise that all to the 1/5 power. So I'm just going to go ahead, I'm going to pause the video, I'm going to distribute all these exponents, which you should be able to handle by now. So go ahead and distribute all your exponents, and then we'll compare what we get from that point. So you can take a look at what I got when I distributed my exponents. And just double check your math here. And then I like to always put the things that have integer exponents, I like to pull in front. So I like to have the 2 and the y cubed in front, and then the fractional exponents as last, just to kind of help myself stay organized. So this one's actually okay. For this one, I think I'd like to have the 3 and then the y, and then I'll have the 2 to the 1/3 and the x to the 4/3. Just, again, keeping things nice and neat. So for right now, I'll have a squared out front, and then I'll deal with the fractions. So if you take a look at the first example, check your exponents. Obviously, all the exponents are integers or proper fractions, so we can go ahead and convert this back into radical form. So we're going to have the cubed root of x squared. And that is completely simplified. Same thing with b. 3/4 is a proper fraction. So we'll go ahead and write 2x squared, and we'll convert this into radical form. So we have the quartic root of y cubed. Now for letter C, the 3 and the y and the 2 are all okay, but obviously x to the 4/3 needs broken up into 3/3 and 1/3. So that's actually going to make x, and then x to the 1/3. I don't want to forget I had a 2 to the 1/3, and I had a 3 and a y. So now what I want to do is have my 3, my y, and my x out front. And I want to put 2 to the 1/3 and x to the 1/3 inside a radical. So I can actually just draw one cubic root, and inside I want to place 2 to the 1st and x to the 1st. So this is going to be my answer. Letter D is going to involve the most work because you can see there's 2 improper fractions. So we're going to have to break this into 2 to the 5/5 and 2 to the 1/5, b to the 10/5, and b to the 3/5. So I know I'm going to have an a squared, 2 to the 1st, so I like to put my 2 in front of my a. This is going to remain a fraction. B to the 10/5 is b squared. And then what I want to do, since these are both fractional exponents, but they both involve a fifth, is draw 1/5 root, and inside I'm going to place 2 to the 1st and b to the 3rd. So then all my exponents are following the rules they should. So what I'll do is in my next video, I'll take you through 4 more problems. They're a little bit trickier. There's some extra steps involved, but totally doable. Just involves a little bit of extra work on our part.